How do I look? Good? Hey there, hi there, ho there, welcome back. This is Unit 5, Minerals and Rocks. Two different things, we'll come to find out. So, we've been spending a lot of time looking at and dwelling in the tectonic cycle, talking about plate tectonics, talking about earthquakes, a number of other things. But we've pretty much been spending time in this realm. So mantle convection caused by Earth's internal heat causes the plates to move around and does all this crazy stuff. Well, excuse me. This tectonic cycle, one of the major cycles of geology, intersects with the rock cycle. And that's where we're going to spend the next few weeks, is looking at the rock cycle. First off, talking about minerals today and a general overview of rocks. Then taking some time to break down, for the next following weeks, to break down the different types of rocks: igneous rock, sedimentary rock, and metamorphic rocks, each another week. So we're going to spend about a month or so in the rock cycle. So this is still the reason the rock cycle exists is because of the interaction between the tectonic cycle, Earth's internal heat causing mantle convection, moving plates around. But it's also, the rock cycle also interacts with the hydrologic cycle and solar energy. And if it wasn't for the hydrologic cycle, the water cycle, and energy we get from the sun, then this cycle would be incomplete. So this is where we're going to spend our next month or so. So let's first talk about the small stuff. We're going to kind of dabble in traditionally some topics that may be covered in chemistry, and I'll try to keep it brief. I mean, chemistry, it's all well and good. We just need to know just a few pieces parts. I don't know if you remember, but this is called an atom. It's made up of protons and neutrons in the nucleus, and there's some electrons flying around here. It's the smallest individual particle that retains distinct chemical properties of an element. For example, if you have a chunk of gold, then it's made up of a bunch of gold atoms. Gold is an element. So whether it's a chunk of gold or one single atom of gold, it is the same. It has the same distinct chemical properties. The word atom comes from the Greek word atomos, meaning indivisible. The ancient Greeks, a few thousand years ago, this is kind of more of a thought experiment. It was, they had this idea, take a loaf of bread, slice it in half, slice that in half again, slice that half in half, slice that half in half. Keep going, keep slicing in half. At some point, you're going to get to the essence of that bread, to something you can't split anymore, something that's indivisible, excuse me. That's where atoms come from. And again, they're made up of protons, neutrons, and electrons. And it's differing number of protons which give us all the different elements on the periodic table. For instance, the element that has one proton is hydrogen, 2 protons, helium, 3 protons, lithium, so on and so forth. They also do have different amounts of neutrons and electrons as well. But it's really the protons that define a specific element. So a substance whose atoms all have the same number of protons are a specific element. Elements are chemically the simplest substance in the universe. Different combinations of these elements create different minerals. Some minerals are just made up of a single element all on their own. For instance, gold, it's Au here. So a bar of gold is just made up of a bunch of atoms of gold. It's just that element, just gold. But a mineral like salt, which is the technical term for salt is halite, is made up of one sodium atom and one chlorine atom. So different combinations of elements create different minerals. However, when we're looking at this 118 plus elements or so, there's really only a handful that are most common in Earth's crust. I mean, you can find, for the most part, all of these, with the exception of some of the rare earth elements, in the Earth's crust. I think from number 1, hydrogen, all the way to, where is it? Where the heck is... I don't know. I got lost. I don't even know what I was thinking. I got kind of a sinus infection. But in any case, you can find most of these in the Earth's crust. However, there's only a handful of them that are common in the Earth's crust. A lot of the other ones are just very, very, very rare, or even some of the elements in the periodic table only exist in laboratories because they're man-made. But in the Earth's crust itself, there's kind of 12 big abundant elements, and then what's left over is all those other elements. So 45.2% of the Earth's crust by weight is oxygen atoms. Not oxygen gas. Oxygen gas, like what we breathe in from the air, is O2. It's two oxygen molecules bounded together. So we're just talking about oxygen kind of combined with other elements to make minerals and rocks. So 45% of the Earth's crust is oxygen. Over 27% is silicon. So just these two make up, what, 72, about 72.5% of the Earth's crust is made up of two things, oxygen and silicon. Let's throw in some aluminum, iron, calcium, magnesium, sodium, potassium, titanium, a little bit of hydrogen, a little bit of manganese, a little bit of phosphorus, and then everything else makes up less than 1% of the Earth's crust. Since these 12 things are the most abundant things in the crust, these 12 elements are the elements that are most common in minerals and rocks. If the crust is made up of mostly this stuff, then the crust, which is minerals and rocks, is made of this stuff. All right? Different layers of the Earth have different consistencies. This is just the crust. This is just the chemical makeup of the crust. So let's take a look at some minerals, some common minerals we find in the Earth's crust. The most common mineral, coming from the most common class of minerals, is quartz, which is a form of silicate minerals. It's made up of one silicon and two oxygen. Going back, remember, these are actually the two most common things in the Earth's crust. So quartz, that can either form these beautiful crystals or sometimes this milky white stuff, is made up of the most common stuff on Earth. Since quartz is made up of the most common stuff in the Earth's crust, it is the most common mineral because it's just made up of the most common stuff. Since the Earth's crust is mostly silicon and oxygen, well, anything that's made up of that stuff is going to be plentiful. Quartz. Related to quartz, with just a little bit of sprinkling of some extra stuff, is olivine. Here's that silicon and 4 oxygens this time, but a little iron or magnesium kind of sprinkled in. Remember, those are up there, the top 12 as well. Again, garnet, some silicon, some oxygen, aluminum, magnesium, iron, calcium. Again, all those little things sprinkled in there. Again, more oxygen, more silicon, potassium, aluminum, a little bit of hydrogen thrown in on this one. This is muscovite. Hematite, oxygen, and iron. Again, the top 12. Calcium, oxygen, and then, but this C is carbon. Carbon making an appearance here. So not in the top 12, but it is, I would probably say, I'm sure it's within the top 13 to 20 elements in the Earth's crust, but it's just, very, very small. So we have some carbon thrown in. This makes calcite, beautiful clear calcite. Diamond is just made of carbon. C stands for carbon. Well, carbon's not on that list of top 12 minerals in the Earth's crust. Therefore, if carbon is rare in the Earth's crust, guess what is also rare in the Earth's crust? Diamonds. That's why they're so expensive. Makes sense? So different minerals have different chemical formulas, some very simple, some a little bit more complex. But most minerals are a combination of those kind of more abundant 12 minerals in the Earth's crust, as we saw a few slides back. So we're going to go ahead and pause here, and when we come back, we're going to look at different characteristics of minerals. The different characteristics of minerals are going to help us identify the types of minerals that they are. Again, quickly going back through, you can pick out some different characteristics, from shapes to colors to, if it's see-through or not, if it's shiny, if it's sparkly, what the crystals look like themselves. So there's a number of different characteristics that we can kind of just pick out quite easily, but also maybe some that you're not aware of. And it's these characteristics, again, that will help us identify minerals. And once we can identify minerals, that will help us identify rocks, because there is a difference. I'll explain more in another video or two. So let's go ahead and just pause here, and when we come back, we'll talk about mineral characteristics. See you in a second.